All right, thank you so much for joining us today. So, we are talking about limit and we talked about continuity and discontinuity in the previous video. Now, we want to look at this type of, discontinuity and how the graph looks like. And then we go through some questions that goes with graph sketching and then, getting your limit from a graph. Right. So first one is removable. Removable, sometimes we call it point discontinuity. So it's kind of something that, we are saying that it's removable because like we can just remove it. So it's kind of if I have a graph like this, right? But this graph that I have some, let's say a hole inside here. No. Okay, let me change my distance so that I can claim some small part here. Good. So I have a hole here, something like that. So this is like a hole, right? So this is like a hole inside this one. So it's kind of like the graph is continuous, but when it gets here, it just need to go around before it just continue. So it's just like this is removable because like we can just make it. For example, this is like the limit exists. This means that the limit exists, but let's assume that it's either the when you plug in the value, it does not exist, or maybe it's giving us a different value, right? So remember continuity, right? So anytime I have a removable discontinuity, we know that the limit exists from there because it's removable. For example, is final limit as s is approaching 1, x minus 1 divided by x squared minus 1. So this one, when I plug in 1 direct, it does not exist. But when I evaluate the limit, you will see that the limit exists. So the limit exists because there is a hole here, and then we are just taking that one out. Now, another one that we can talk about is the jump discontinuity. So jump discontinuity, as the name implies, is like jump, right? So I just like maybe I'm just continue here. Then when I get to this place, I just jump to, let's say, here and just continue from somewhere here. So this is kind of jump discontinuity. So with a jump discontinuity means that the limit does not exist. So here, let me write it something here for you. The key here thing is anytime we are talking about removable, the limit exists. Removable, limit exists. It implies that limit as x is approaching a from the left of f of x is the same as limit as x is approaching a from the positive of f of x. So you can see that from the right, we are getting the same value. From the left, we are going to get the same value. But it's just like when you plug in the value, let's say f of a, it's this one does not exist, or maybe the value that is giving us is different from what is given here. So that's the reason why this is, a type of discontinuity. Now, this, anytime you have something like this, like a jump, here the limit does not exist. Limit does not exist. Why? Because the left is different from the right. So let's assume that this is giving us 2, -2, and this is giving us 1. So we see that here limit as s is approaching a from the left of f of x is not the same as limit as x is approaching, let me say, a from the positive side. So I can shade one of this one here. It means that one of the limits is, the same as when I plug in the value a. So these are types of discontinuity, and I can talk about infinity discontinuity. Infinity discontinuity is like, if I want to find, let me assume that this is my graph, and then this is where x is equal to a. So when I'm approaching this one from the left, let me assume I'm going this way, and I'm approaching from the right, I'm going this way. So this is kind of infinity discontinuity. So as we said, this is kind of like whenever you simplify the limit, and let's assume that you are having limit, let's say 1 divided by, let's say, x minus 1. So this one we cannot simplify, so we need to check the infinity discontinuity, and we see that this one does not exist. Maybe this one is going up and this one is going down. So these are the three types that we need to, learn. We have some other types when we have some sharp curves, all those things. But I think these three types of discontinuity, if you know them, it's going to help you a lot. So now let's look at some graph works that we can also work with, right? So consider the graph, this graph here. Now you see that at times when they give us the question, they give us the functions to work with it. But this one, they've given us the graph and we want to determine this limit, right? Or evaluate this limit. So let me show you how to, choose your limit from a graph. Now you see that the graph, anytime you see something shaded, right? These are for, let me assume that you plugging in direct the values. So for example, f of minus 3, anytime you are looking for f of minus 3 on the graph, you need to look for the one which is shaded, right? Which is close. That's what we are looking for. And then anytime you are looking for this one, these are the one that uses the lines to do it. So let's go through and see. So what's the first one that we are going to do? Now the first one, we want to look for f of minus 3. So we need to go and look for minus 3 on the x-axis. So anything near here. So minus 3 here is on the x-axis. Minus 3 is having this and that. But as I said, since this is not a limit and it is f of minus 3, then we need to pick the one which is what? Shaded. So the one which is shaded is here. And when I trace this one to the y-axis, it is 0 because it's on the x-axis. So this is basically equal to 0. Like very simple, just like that. Now let's look at B. B, want to look at limit as x is approaching minus 3, but from the negative side. So anytime you are dealing with limit, this is what you need to do. Look for what x is approaching. So x is approaching negative 3. So let's go to the graph. Negative 3 is here. So what I'm going to do is I'm going to draw a line which is going to pass through negative 3. As soon as I get this line here, remember the right side of the line becomes the positive side. Whether the values here are negative or not, they are the positive side. And then the left side becomes the negative side. So with this line where we have the negative 3, this is the positive side, this is the negative side. This helps a lot. Now this helps us to now check it out. So you see that now we are looking at negative 3 from the negative side. So it means that we are on the left here. So now for us to get this answer, let's look at the graph on the left. So the graph on the left is basically this. So what I'm going to do is I will trace along the graph on the left of this line, but I will head towards this line. So this is the graph on the left. So when I'm moving up to this line, this is where I meet the blue line. So now I go to the y-axis and this is going to give us 0. So this is going to give us 0. Now let's look at C, we see that this one we are looking at the positive side. So this is the positive side. What's the graph on the positive side of negative 3? Is this graph. So now let's move along, getting close to the blue line, right? And we see that this is where we meet the blue line. So we trace it to the y-axis and we have negative 1. So this is going to give us negative 1. So it's kind of very simple to just go with that. Then what can we say about limit as x is approaching minus 3? So we learned about left side and then right side when we are talking about limit. So for us to talk about this limit, we see that this limit does not exist. Why? Because this is not the same as this. And even looking at the graph, let me clean the what I've put in on it. So looking at the graph, you can see that this is a jump discontinuity as we just learned here. So this is a jump discontinuity. So anytime you have a jump discontinuity, the limit of the original value does not what exist because the left is not the same as the right. So that's one way of seeing this. This is a jump discontinuity. Let's look at E. E, we want to look at f of 2. So let's indicate 2. This is 2. And then we don't have anything on the 2. Okay, I think I didn't choose that one. So let me have the 2 somewhere here. Okay, I should have brought the shading here. So the one with the shaded on the 2, this is open, this is closed. So we need to choose the closed one. So this is going to give us minus 2. Right. Now we want to look at limit as x is approaching 2 from the left. and then limit as x is approaching 2 from the right. So the same idea, let's draw some line on the graph like this, right? So now since x is approaching 2 from the left, now this is the left side and this is the positive side. So since we are looking for the left, let's trace the graph that come to the left. So this is the left and we trace it up till we get to the blue line. This is where we get to the blue line, and this is 1. So this is going to give us 1. And then on the right is this side. So this is a graph on the right. So we trace it up till we get to the blue line, and this is here, we go here, and this is 1. So this is also going to give us 1. Then what is the limit for this? Since this is 1 and this is also 1, this is going to give us 1, or we are going to say that it exists. And let me clean up something for you to see something here. You will see that this graph here, it's actually the removable or the point discontinuity, as we saw from here, right? So it's a removable or a point discontinuity, and we said the limit what exists, but it's just not continuous, but the limit what exists. So anytime you have a point discontinuity, the limit exists. It's just that it is not continuous. So you see that now if we are from this stage, if we are talking about continuity, this is not continuous. Now here the limit exists, but this is not the same as this. So this one too is not what continuous. Now let's look at the last one here, f of 5. F of 5, I have some example here to give you to practice, so don't worry. F of 5, now let's look at the 5. This is 5, this is open, this is close. So since it's this one, we pick the one which is close. So close is going with 4, so this is going to give us 4. Now we want to look at 5 from the left, from the right. So let's put our line on it. So we put the line. So this is the right, this is the left. So on the left, I just move towards this line and I get this place, and this is going to give us 0. So this is 0. On the right, we move towards the blue line, we get here, and this is also going to give us 0. And as you can see, you will see that this is actually a point discontinuity or removable. So the limit exists, because the left will be the same as the right. And this is also going to give us 0. So you see that this is kind of like very simple, right? And this is actually talking about discontinuity. So you can see that everything here for the first set, it is discontinuous, and this one too is also discontinuous. Why? Because even though these are the same and the limit exists, but this is not the same as this, so it is not what continuous. Same thing to this one, and then same thing to the last one also here. Now that we know how to, get the limit from the graph, let's look at when the information is given like this and you need to sketch. So it's very important. So you see that this one was sketched. This graph here, I can sketch this graph here using this information. So now let's use this information to also sketch the graph. Now I want to sketch this graph. Anytime I see something like this, everything here is kind of the one after the equal to sign. I call it horizontal asymptote, and then the x values here, I call it a vertical asymptote. So that's basically what you need to have it in mind, like something that you need to have it in mind whenever you are sketching. So everything here is going horizontal, like horizontal asymptote, and everything here is like vertical asymptote, right? Now another thing that you need to know is anytime you see something like it does not exist, what comes in mind? Remember, we talked about discontinuity. So anytime I see that the limit does not exist, it means that the left is not the same as the right. So limit as s is approaching 1 minus 1 from the left of f of x was not the same as the limit as s is approaching minus 1 from the positive side. So this one was true. That was the reason why this does not exist. So that's one thing that you need to have it in mind. So it does not exist. So now another way of doing this is anytime you want to sketch the one with, is unfortunate that I don't have, let's say, so let me add one thing to it so that I will show you what I was trying. So let's assume that we have f of, let's say 2 is equal to, let's say, 1, right? So anytime you have something like that, the first thing that you need to sketch is you need to sketch something like this. These are very simple to sketch. So this one is where x is equal to 2. So let me name my graph. Here is 1, this is 2, and this is 3, right? This is 3, this is 1, 2, and this is 3. So I need to sketch this one. This is x is equal to 1 and y is equal to, sorry, x is equal to 2, y is equal to 1. So x is equal to 2, y is equal to 1 will meet here. So I'll just do something like this. So you see that I just did it close like this, as we did it in the other video. So this is what I'm going to have for just this. So anytime you have this function, this is the first thing that you need to sketch. When you are done with this one, you now sketch the one with x approaching a specific value. Don't go, the one that x is approaching infinity should be the last one to sketch. So now let me sketch s is approaching -1. So let me put my -1 here, -2 here, and -3 here. So we see that at -1, the left is not the same as the right. So it's basically going to be something like jump discontinuity. So anytime I see something like this, I know that it is a jump discontinuity. So jump. So it means that if I'm at 1, I can decide to, since we don't know the exact value for the left and then the right, we can pick any value. So I can say that from the right or from the left, I'm picking here. And then maybe from the, so this one you can sketch it anyhow because we don't have any point. I can pick maybe one value from the down, but you can also pick it from the top. So I can pick somewhere here. So let me assume that this is coming from the left and this is coming from the right. So the left is not the same as the right. So when I'm coming from the right, we are assuming that we are getting -2. When I'm coming from the left, we assume that we are getting 1. So 1 and -2 are not the same. So that's the reason why this does not exist. It's a jump. So you see that I didn't sketch the graph because I'm not done. I'll combine all the graphs together. So I'm done with the last one. Now let's look at x is 2. So x is 2 is somewhere here. And when I'm approaching this guy here, it's kind of from the negative side, I'm approaching infinity, right? So I need to go to infinity. And this infinity here is positive infinity. So you see that when I'm approaching this here, when I'm approaching it from the left side, I need to go positive. Remember, this is the y values. So I need to go to positive infinity. And when I'm approaching it from the negative side, I need to, when I'm operating from the positive side, I need to go to negative infinity. So because of that, I'll just sketch something small here for you to see. So on the right, I'm going negative infinity. And then on the left too, I'm going to positive infinity. So you see that at 2, I've indicated it, but I've not drawn the diagram. So you see that I'm going to negative infinity, I'm going to positive infinity on the left and then on the right. So I just want to have the sketch before now I combine them together. Then now this guy is telling us that when I'm coming from the negative infinity, when x is approaching negative infinity, I need to go to positive infinity. So the last x term is this. So when x is approaching negative infinity, when we are approaching negative infinity, we should be going positive infinity. So it's kind of something like this. This is where x is approaching negative infinity, right? And when we are approaching negative infinity, we should be going positive infinity like this. So I'll just have another sketch like this telling us that we should be going positive infinity. So I've done this one too here. Now this one is telling us that as x is approaching infinity, we need to get towards 2. So now we need to look at, for us to talk about x is approaching infinity, we need to look at the last x value on the positive side. So the last x value on the positive side is x is equal to 2, which is we have it here. So after 2, we are saying that when x is approaching positive infinity, we should be approaching this horizontal line here. We should be approaching these 2. So I'm going to have a nice horizontal line from the 2 here. And then the graph that I'm going to draw, after 2 should be approaching -2 whilst I'm going to infinity. So I'm done with this one too. So you see that every information is on the graph now. So now I can sketch. So how am I going to sketch? I'll start from this side. So you see that I have one tail here going to -infinity. But this one, when it's going to -infinity, we are saying that we have another graph that goes to +infinity. So it means that I can combine this graph and have something like this. Do you see that? So like combine the graph like this, and this goes to, after -1, as we are approaching -infinity, we go to +infinity. Good. Now with this one too, we have this one here, and this is going to -infinity, and this one too is going here. So I can combine this graph together. Is that right? So we are combining it. When I finish, I'll sketch it very nice. And then we look at this graph and we see that this graph to, when we are approaching this guy from the -infinity, we basically move towards what? +infinity, right? So I think I didn't sketch the graph well, so it should be, the arrow should be getting towards this, right? It should be getting towards 2, as this one is getting towards 2. So you will see that there is one graph that is going this way and another one going this way. So I can combine this one like this. So I can combine and have something like that. Good. So I'm almost there. You will see the graph. So let me just combine it nicely here for you so that you will see what I was trying to do. I don't want to clean it. So let's see what I was doing here. So we have 2. Let's pick the values that we have here. We have -1, right? So, and we have 2 here. So looking at the graph, we see that at 2, if 2 is the vertical asymptote, and then I should be having horizontal asymptote here, which is the 2, and then the graph is going to be something like this. So this is the graph that I just drew. So it's going like this towards the 2, right? So this graph is telling us that if I'm going to +infinity, I'm approaching the 2, as the question was telling us here. +infinity, I'm approaching 2. And then when I'm approaching 2, where I'm going to -infinity. On the positive side, I'm going to -infinity. So this is the graph that I've drawn here. Now let's look at the one here. The one here to start from, we pick, so this one I can decide not to do. So we pick the point somewhere here, and we are saying that this is going to the right, but we need to approach 2 from the positive side. So this is going to give us something like that. Now horizontal asymptote we can cut, so it's just going to be something like this. And then the last one is, I think the point was somewhere here, and then this one is going to +infinity, like that. So this is how the graph is going to look like. So it's kind of, if you want to draw, you need to be sketching them small. So whenever you are doing it, you should be using pencil to draw it, so that when you finish, you can just do them together to see the clear picture. Or maybe if you can use the small sheet or question paper, do this thing on it, and then when you get the idea, then you sketch the original graph on the function. So this one tells me everything about this information, right? It tells me that if I'm approaching 2 from the positive side, I'm getting to -infinity, which is true here. It tells me that when I'm approaching 2 from the positive side, I'm getting to +infinity, which tells us, and it is also true. It's also true. And then when I'm approaching, x is approaching -infinity, I go to +infinity, which is also true. So x is approaching -infinity and we go to +infinity. So this is basically the information here. And this tells us that the limit does not exist, which means that it is jump, and indeed it is a jump discontinuity, meaning that the left is not the same as the right. Good. Let me do this one and then give you the next one to try it and leave your answer in the comment section. So this is very quick. I see that this is a jump discontinuity, and this is a removable because the graph is going like this and we have the point inside, right? So limit as x is approaching -5 from the negative side. This is my -5. The negative side is this. So draw the graph that's on the negative side here. This is my negative side, this is my positive side. So the graph up to where the red line is this one, which is going to give us 4. So when you understand it, it's very simple to get it. And then from the positive side is this graph coming here, and this is going to give us -3. So this is going to give us -3. So limit as x is approaching -5 does not exist, because we know that it's a jump discontinuity, right? And then the left is not even the same as the right. Then what is f of -5? F of -5 is the one which is close. So that one is going to give us 4. So this is going to give us 4. Let's do the last one. Now the last one, the question is asking us limit as x is approaching 1. It's not telling us from the negative or positive, but for us to talk about this one, we need to think about the left and then the positive side. They didn't ask us the positive side, but we can look for it and see if it is true. So 1 is here. So I have my 1 somewhere here. This is the positive, this is the negative. So on the negative side, we are getting 0. And then on the positive side too, we are getting 0. So it means that this is 0 and this is also 0. So this is going to give us 0. And we can see that this is a removable. So the limit exists at this point, which is 0. So we are going to get 0. And f of 1 is the one which is close. So it is 2. So it's basically very simple to just go through when the graph is given. The one which is very difficult is the one that we did here, sketching the graph yourself. But when the graph is given and you are picking out the limit, this is very simple to go through. So I want you to go through this graph here. So look at the graph and do A to E, right? So look at the graph. Let me just position the graph for you. So look at the graph and do this and that, and then the E. Let me write the E here so that you can see it with the graph. So limit x is approaching 4 from the positive side, f of x. So this is the E. So look at the graph and then do this one and leave your answer in the comment section. Then when you are done with this one too, I'm giving this one to you. Just draw it. You cannot send it to me, but just try your hand on this graph here and see if you can sketch it, right? Try your hands on this one. So when you are sketching, try and sketch this one first. So this one first, then you can think of now the one with the fixed values. And so you can also try to sketch this one second, and then followed by this and that. And then now you can focus on when x is approaching -infinity, which is equal to 2. Yeah. All right. So I think this is the end of the video. So in the next video, what we are going to do is we are going to take a sample quiz on limits. And when we are done with that, then we start derivatives. As I said, derivatives and limit, most especially derivative, are very important because throughout your math journey, differentiation, integration, limit is like kind of something that you are going to use them a lot, differentiation and integration. So after our sample quiz, we are going to look at differentiation, and right from differentiation, we'll look at integration. See you in the next video.